Good morning, everyone. In this video, I'm going to go over Tuesday's page from the Week 14 packet. So the first thing you need to do is write down the units that are used to measure each of these quantities below. You can pause the video here and write down everything you remember. And then please check your work to make sure that you have the units correct. Here are some tips for answering questions about energy, work, and power. The rate at which work is done is equal to power, and that's significant because some multiple choice questions, instead of asking you how much power is developed or what is the power, they'll say what is the rate at which work is done, and you have to remember on your own that you're actually solving for the power. Something else you need to know is that when you're calculating work, the force and distance have to be parallel. So if you're using this formula, W equals FD, you have to make sure the force and distance that you're choosing to plug in are either pointing in the exact same direction or opposite directions from each other. If you need force for a formula and the problem gives you mass, you can use Fg equals mg to find the force. And you also need to know that a motor changes electrical energy to mechanical energy, and a generator changes mechanical energy to electrical energy, so they're basically opposites of each other. Question 1 is asking you, what is the rate at which work is done in lifting a 35 kilogram object vertically at a constant speed of 5 meters per second? I annotated according to cubes. If you choose different keywords than me, that's completely fine. But the important part is I underlined this question, what is the rate at which work is done? And I can remember that that means I'm solving for power. They also gave me 5 meters per second. And I know that that's a velocity. Once I know that I have power, or I'm looking for power, and I have the velocity, there's only one formula that matches, P equals FV. So I can go ahead and write P equals FV. That's definitely the formula I'm going to be using. Unfortunately, I wasn't given the force, I was just given the mass. So I can use the formula Fg equals mg to solve for the force. Fg is what I'm looking for. M was given to me, that's my 35 kilograms. And g is something I'm supposed to know on my own, 9.81 meters per second squared. If you forget that, it is on your reference table, but it's hard to remember to look it up. But it's right here on the first page, acceleration due to gravity, 9.81 meters per second squared. So I can use this to find the force of gravity. 35 kilograms times 9.81 meters per second squared. To get my answer, I'm just going to be doing 35 times 9.81. And that gives me 343.35. I'll just round it to 343. My unit is newtons because this is a force. Now I'm ready to plug in my force into this equation. So I'm just going to have 343 newtons times 5.0 meters per second. And I will multiply those two numbers together in my calculator. That gives me 1,715. My unit is capital W for watts, and so A is my answer. On the Regents, they round, so they rounded 1,715 watts down to 1,700, and that is your correct answer. Question 2 requires a lot less work. It just asks you what energy transformation occurs in an operating electric motor. So you can check your notes to answer this question. You can also remember that an electric motor is similar to something that is motorized. You can imagine a motorized car or a motorized helicopter. Any motorized toy that you can turn on, it requires electricity and it moves. So we're looking at choice A, electrical to mechanical. It requires batteries or some electricity, and then it moves. and that's the energy transformation. Question 3 is asking, what is the kinetic energy of a 55 kilogram skier traveling at 9.0 meters per second? So I'm going to start by listing my variables. They're asking me for the kinetic energy, so that's going to be my question mark. At that point, there's only one formula for kinetic energy, so I can just write down Ke equals 1/2 mv squared. They gave me the mass. It is 55 kilograms. They also gave me the velocity, 9.0 meters per second. I'm copying down Ke since that's my question mark, making sure I copy down the 1/2, and then the mass is 55 kilograms, velocity is 9.0 meters per second. This is a multiple choice question, so you don't actually have to show your work. However, if you choose to show your work, or if you're asked to do this in an open-ended question, the squared goes outside the parentheses, and that means that it does go into your calculator. So when you type this into your calculator, it should be 1/2 times 55 times 9.0 squared. When I type it into my calculator, I got 2,227.5 joules. That matches with answer choice C. If you're not sure what the scientific notation means off the top of your head, you can just pick the one that looks the most similar and plug it into your calculator to double check. So if I plug 2.2 times 10 to the 3 into my calculator, it will look like this, 2,200 joules, and that is closest to 2,227.5 joules. For question 4, you have to pick which graph best represents the relationship between the potential energy stored in a spring and the change in the spring's length from its equilibrium position. You need to basically look at the formula that applies, which is PES equals 1/2 kx squared. The easiest thing to do here is just look at potential energy and change in length to pick your formula. Potential energy, we know that there's two separate formulas, but either you can see that it says spring and automatically use PES, or you can look at change in length and you can kind of know that that means x and match it up that way. Either way, this is the formula we're looking at, and because they are asking about the change in length, we're looking at x. All you have to do is see if x is squared. If x is squared, we're looking at a curved graph like this. If x was not squared, we would be looking at a straight line graph like this. So these are the only two types of graphs we've really learned so far. It's just a straight line graph, directly proportional, and then this one, a curved graph, directly proportional to the square of a variable. So the answer is choice 1 for question 4. For question 5, it's another graphing question, but now we're looking at kinetic energy and speed. Ke equals 1/2 mv squared. Speed is the variable that we're changing, so I would look at v, and I see that yes, it is also squared, meaning choice 3 is my answer. It's going up, but it's going up at an increasing rate. It's a curve. Once again, you can eliminate 2 and 4. We have not yet learned graphs that look like those shapes. We just have 1 and 3, either directly proportional if it's not squared, so if I had mass here, it would be like this, or proportional to the square of a variable, increasing like that, with a curve. For question 6, it says a horizontal force of 20 newtons eastward causes a 10 kilogram box to have a displacement of 5 meters eastward. The total work done on the box by the 20 newton force is what? They're asking me to solve for work, so I'm just going to start by writing W equals question mark. They told me that there's a 20 newton force. I put a box around eastward so that I can make sure it matches up with my distance. If my force is 20 newtons and it's eastward, whatever distance I choose must also be in the east direction, or displacement. And so they gave me a displacement of 5 meters, and it does match because they're both east. So I'm good to go. 10 kilograms is extra information. I don't need that. It does not show up in the formula, and they already gave me a force that matches with the distance, so there's no need to try to change this into a force of gravity. So I'm just looking at 20 newtons times 5 meters, and that's 100 joules.